So in a geometric sequence, we know term 1 and we know term 5. We want to find term 2. So we know term 1 is a 7. We don't know term 2, we don't know term 3, we don't know term 4. We know term 5 is 567. And we don't know term 6. Can you see it would be really helpful that if we knew what R was, if you knew the common ratio, you could figure out what that next one would be. Two ways to go about this question. And I'll show you two ways. The first way is probably the most practical for this one, but the second way might be helpful if the question was slightly different. So the first thing I would do is say, like, oh, I don't know R, maybe I could use my formula. So if I write out my formula, there's my formula. What do I know? Do I know term 1? Yes. Do I know another term? Yeah, I know term 5. So because I know another term, can you see that you can plug everything into this equation except for the R? That term 5 is 567. So if we make n equals 5, term 5 we know, term 1 we know is 7, and we just don't know R. Lots of the geometric sequence questions are calculator. So if I divide both sides by 7, I get 81. How do I get R by itself if it's R to the 4? Any ideas? We do the 4th root. So if I do the 4th root of this side, I would do the 4th root of this side, and then I will get R by itself. And just like squaring, what do you have to remember when you square root both sides? That it could be positive or negative. Remember that? If you have x squared equals 9, then x could be 3 or x could be negative 3. The same thing happens with 4th roots, 6th roots, 8th roots, any even root. It could be plus or minus 3. So if it was plus or minus 3, does it make sense that term 2 is going to be either 21 or negative 21? And then term 6, go to my calculator again, multiply that by 3, could be 1701 or negative 1701. Mathematically, if you just did 21 and 1701, that's a right answer, but it's not the complete answer. You do need to show both of them because the R value could be negative. Okay? Sometimes what's going to happen is you're going to get this same question, but instead of term 1 and term 5, they might tell you term 21 is 7 and term 25 is 567. You know how we did those ones in our first chapter, where you had to like temporarily think of things as term 1 and term 2? That's basically our first method. But we didn't have to temporarily do anything because term 1 was term 1. But we also learned that other method where you could find R by using this idea. If I started with 7, how many times would I have to multiply by R before I got to 567? I could start with 7, and I could multiply by R 1, 2, 3, 4 times, and then I know it equals 567. Notice that sets up exactly the same thing as the formula, But this time we didn't use the formula, we just thought about how would I write an equation based on the information I was given. And then from here, you could get r as plus or minus 3 as well. Okay, so part B. The last term in the sequence is 497. So in these last term questions, we make this value equal to term n, and then we have to find out what the n is. If that's the last term, then we make that equal to Tn and try to find out what the n value is. So again, something that I mentioned in the other class, sometimes when we use Tn, we talk about it being the general term. And sometimes we use Tn for the last term. So in this case, we would know for part B, we would say, I know that the last term is equal to 45,927, and I need to find n. If I find n, then I would know how many terms there are. My general term formula was this. Term 1 was 7. R is 3 or negative 3. In this case, I would use, because this is a positive number, it's not going to be wrong if we use positive 3 to the n minus 1. So I plug in 45,927 in for Tn. Order of operations become very important in geometric sequence questions. You are going to be very tempted sometimes. You see that 7 times 3, they're so close to each other. Your brain might be like, oh, I know 7 times 3. That's 21. Not allowed, right? Order of operations, exponents have to happen before multiplying, and that n minus 1 is an exponent to the 3. You are not allowed to do 7 times 3 unless you've done the exponent first. What's the problem? Can't do the exponent. So you're not allowed to do that 7 times 3. But you will be tempted. Math is bad that way. They keep throwing out things and they're like, hey, you should do that 7 times 3. You should impress the person beside you. You know your times table. Come on, 7 times 3. Put 21. No. But what we can do, we want to solve for the n. The n is in the exponent. I can get rid of this 7 by dividing both sides by 7. So that's going to give me 3 to the n minus 1 equals, and 45,927 divided by 7 is 6561. Now the next step is going to bother you a little bit as a pre-calculus student. Pre-calculus students like algebraic ways to solve things, and I can't teach you the algebraic way to solve this until grade 12 next year, where we learn logarithms. So we have to do a little bit of guessing and checking with our calculator. One thing you know is that n has to be a nice number. You can't have term 32.65. It's going to be a nice whole number. So I'm going to go to my calculator, take my calculator out, and I'm going to do some 3 to the 6, 729. Is that, I want 6561, so do you see I have to go bigger, right? It doesn't take you too long. Maybe you jump too big. Oh. Well, there's only 2 numbers left to guess, 7 or 8. What are you going to go with? 7. Oh! There it is. It was 8. So, we've got this side, you can change to 3 to the 8. And this side is 3 to the n minus 1. And now take some brilliant mathematics. You should be able to tell me what n is as a result. Just looking at it. What do you think? 9. Brilliant. Right, because if they're the same, if these two things are the same, does it make sense that this 8 has to equal this n minus 1? And then what could n possibly be if it equals 8? We get n is equal to 9. So what was this question asking? Always good to reread. How many terms? You can write a sentence. There are 9 terms. Okay, circle questions 8, 9, and 11.